As we start chapter 2, really the goal of chapter 2 is a process called solve right triangles, or solving right triangles. Now, first off, what does it mean to solve a triangle? Well, suppose I have any right triangle. Eventually, our goal is to say, okay, what if it's not a right triangle? How do you handle that? We'll deal with that later on. But for now, we already have just about enough tools in place. We'll throw a few more here in just a little bit. With the tools we're going to have in place, we're going to be able to solve a right triangle. Now, here's what that means. Every triangle, let's assume I call this triangle A, B, C. There are a few standard agreements we all use. The first, unless there's some reason not to, and that reason could be anything, unless there's some reason not to. If you're going to label a right triangle ABC, if you have the option, this is a big if you have the option, you should make the right angle angle C. You don't need to, but that's typically what we do. Also, if this is angle A, the side opposite is lowercase a. If this is angle uppercase B, this side opposite is lowercase b. If this is capital C, the side opposite, in this case the hypotenuse, is lowercase c. All right? So that's standard. Also some things we know. We know the hypotenuse is always the longest side of a triangle. If it's not a degenerate right triangle, we know the hypotenuse is always the largest side, the longest side of the right triangle. We know that A and B are both less than C, unless this is the degenerate triangle, which we're not going to deal with for now. So we have that. There are 6 pieces of a triangle. 3 angles, 3 sides. Since, for now, we are working with exclusively right triangles, that means the right angle must be given, or deducible from what's been given. So the right triangle must be known. So really, for now, there are 5 pieces. We know we have a right triangle, a right angle. So one of the angles is known to be 90. Our goal is going to be to find the other 5 pieces. The other 5 pieces, if angle C is the right angle, then the other 5 pieces are angle A, angle B, side little a, side little b, and side little c, because we know angle C is given to be 90 degrees. So our goal, when we solve a right triangle, it means to solve any triangle means find all 6 pieces. For a right triangle, we know one of them is a right angle. So our goal now is to find the other 5 pieces. We have a few things yet to get from here to there, but that's essentially going to be our goal. One tool to do that uses this notion. So, given one of the acute angles in a right triangle, one of the acute angles in a right triangle. One of the acute angles in a right triangle. Doesn't matter, A or B, just pick one. For now, let's suppose I pick angle A. So I am working this problem from the perspective of angle A. I am working this problem from the perspective of angle A. The sides now have special names. One of them is called the adjacent side. One of them is called the opposite side. One of them is called the hypotenuse. Now, the hypotenuse is easy. The hypotenuse never changes. I don't care if you're talking about angle A or angle B. The hypotenuse never changes. By the way, is it clear? If it's a right triangle, if angle C is 90, then both A and B must be acute. They must be less than 90 degrees. And so given one of the acute angles, from the perspective of one of the acute angles, we have hypotenuse, we have adjacent, and we have opposite. Now, which is which? The hypotenuse is always the side opposite the right angle. Hypotenuse, and I will abbreviate hypotenuse hypotenuse. It's the side opposite the right angle. It's the side opposite the right angle. Little c in this case is the hypotenuse. Then we have what's called the adjacent side, which I will abbreviate ADJ. And then we have the opposite side, which I will abbreviate OPP. This is standard. Everyone does it the same way. You might as well join the club. There's the hypotenuse, there's the adjacent side, there's the opposite side. The hypotenuse is obvious. It's the side opposite the right angle. The adjacent side, I'm not going to write this down because it's not important that you know the definition. It's important that you know which one's the adjacent side. For angle A, the adjacent side helps to form the angle. It is one of the sides of the angle in question. In this case, angle A is we've chosen angle A because I just randomly chose angle A. Hypotenuse is C. So which of A or B is adjacent? Which of A or B is adjacent? Well, B is one of the sides of angle A. Do we see it? B is one of the sides of angle A. B is the adjacent side. Adjacent means standing right beside it. Look, it's right beside it, right? So B is the adjacent side. In this case, the adjacent side helps to form, or forms, one of the sides. It helps to form one of the sides of the acute angle. The opposite side is the other one. There it is. It's the other one. It's the side on the other side of the triangle. It's on the other side of the triangle. So here's A, side A. In this case, lowercase a is the side opposite. This is the angle of perspective. Then this is the opposite. This is the angle of perspective. This is adjacent. This is the angle of perspective. That's the hypotenuse. So the opposite side it's the other one. It's a self-defining word. It's the side opposite. Because if you know side opposite the hypotenuse, if the hypotenuse is side opposite the right angle, then the side opposite A is the side that's opposite A. It's a self-defining term. All right, so now, suppose I use the blue chalk now. Suppose I'm looking at it from the perspective of B. Well, which is the hypotenuse? Well, the hypotenuse is always the same. The hypotenuse is C. But notice, from the perspective of B, A is adjacent. Do we see that? From the perspective of this angle, this is adjacent. It's right beside it. It's adjacent. It helps to form the angle. From the angle B, this side is opposite. Now, don't get fooled by the lettering. It could be later on for reasons that we don't know about, reasons that come later in the course. We might be given this right triangle. We might be given that right angle. And the lettering might be J and W and K. And this might be little k, and this might be little j, and this might be little w. And we might, for some reason, we don't know why, we're going to choose the perspective of angle K. So from the perspective of angle K, which one is the hypotenuse? Well, the hypotenuse is always the same. The hypotenuse is always little j. All right? From the perspective of K, which side is adjacent? Do you see it? Adjacent? Adjacent is right beside it. Adjacent helps to form the angle. Adjacent is W. And then opposite is lowercase k. So you're thinking, oh, it's always the same letter. Not always. That might not be the case in your particular problem. Maybe this is what you're dealing with. Maybe you're given this triangle, and for reasons we don't know why, this is R, this is B, this is W, this is K, this is M, and this is lowercase p. For some reasons we don't even know why. And now we need to choose one of the acute angles. It doesn't matter which, let's just pick one. So from the perspective of, let's say angle B. From the perspective of angle B, right, from angle B, The hypotenuse, which is the hypotenuse? Well, the hypotenuse is the side opposite the right angle. The hypotenuse is K. From angle B, which side is adjacent? Which side is adjacent? Well, which is it, K or P? Which side's adjacent? Well, K is the hypotenuse. It's already spoken for. So P is adjacent. And then the other one is side opposite, which in this case is M. So being able to identify that is absolutely it's just bedrock fundamental. That just needs to be part of your mental furniture. All right? Now, the next piece is this. SoHCA. SoHCA. SoHCA is how you solve a right triangle. SoHCA only applies to right triangles. SoHCA. Every trigonometry student in the world knows SoHCA. Join the club, SoHCA. What that? This sounds like some weird, Native American name or something. SoHCA. It's an acronym, or I suppose acrostic, I guess is the right term. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Given that, and a little bit of algebra, you can solve a right triangle. So let's look at the basic ones here. P, K, M. Let's call this A, B, D. All right? Given. In order to solve a triangle, you must be given 3 pieces. You must be given 3 pieces. If you're not given 3 pieces of the triangle cannot be solved, not just by you, but by anybody. You must be given 3 pieces of the triangle. For us, for now, since we're at the very beginning of the course, not the very end of the course, one of the given pieces must be a right angle. So you must be given a right angle and 2 more pieces. And for our purposes, for now, at least one of the pieces must be a side. All right, so here's how we're going to do this. All right, suppose we're given angle P is equal to 90 degrees. Suppose we're given angle K is equal to, it can be any acute value. Let's suppose angle K is equal to 38 degrees. I'm just picking numbers out of the blue sky. Suppose that side B is given to be 47. It can be feet, it can be inches, it can be miles, it can be centimeters, it can be whatever. I'm going to forego writing units because the units are irrelevant. If they are irrelevant, then they're not relevant. And we're asked to find. Now, let's not solve the whole triangle. Suppose we're just asked to find what are the other sides? Let's find A. Find side A. All right? This is straightforward. If you know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, you're good to go. All right? B is the hypotenuse, and B is given to be 47. Angle P is given to be 90. And angle K is given to be 38 degrees. So this problem is being done from the perspective of angle K. Remember I said you need to know what perspective of which angle. Well, in this case, we're given K is 38 degrees. So everything in this problem is being done from 38 degrees point of view. From 38 degrees point of view, which one is hypotenuse? Here. Which one is adjacent? here. Which one is opposite here? From the perspective of K. Now, here's the procedure. Here is the procedure. From the perspective of the angle in question, one of the sides is given, one of the sides is desired. One of the sides is given, one of the sides is desired. Given, desired. All right? The given side, see, given side is hypotenuse. The desired side is A. Which is A? Is that opposite or adjacent from here? It's adjacent. So we're given opposite, we want to find adjacent. Given opposite, we want to find adjacent. Which of these functions involves hypotenuse and adjacent? Which of these functions involves adjacent and hypotenuse? Adjacent and hypotenuse. It is right here. You choose the function that has those two pieces. How do you know which two pieces? One of them is given, one of them is desired. We are given hypotenuse, we're asked to find adjacent, so opposite doesn't enter into this problem. Doesn't come into play. You choose the function that uses adjacent and hypotenuse, that's going to be cosine. After that, you just write it down and it almost solves itself. Write it down, it almost solves itself. Cosine of theta, and just write it, is adjacent over hypotenuse. Cosine of theta is adjacent over hypotenuse. The angle in question is 38 degrees. Make sure you write degrees. If you don't write degrees, you're not getting it correct. Degrees. Adjacent. Adjacent is don't know yet. That's what we're looking for. Hypotenuse is given. That's 47. We have a fraction equal to a fraction. Always, 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 always put it over 1. We have a fraction equal to a fraction. We're going to cross multiply, set them equal in just a minute. Fraction equal to a fraction, cross multiply, set them equal, and solve. Now, how much is cosine 38? Calculator. Now, you are going to need to know how to figure out how to make your calculator find cosine of 38 degrees. You're going to need to make sure you are in degree mode. I can't tell you through the screen how to make your calculator do this. You're going to need, if you don't already know how to make your calculator work, you're going to need to either consult someone or use the internet and do a search on Google or something to find how to make your calculator. Some calculators, you must hit cosine first and then 38 degrees, or just 38. Some calculators, you hit 38 first and then hit cosine. If you're using your phone, you need to hit 38 first and then hit cosine. If you're using a calculator like this, you hit cosine first and then 38. Now the rule I use is this. Round it to 4 decimal places. Round it to 4 decimal places.